Okay, hi guys. So in this lecture, we'll be starting off on the discussion of isoelectric point, okay, which is also called PI, okay, isoelectric point. It's also called PI. Okay, so first we have this compound CH2 CO2 minus. It will undergo. It can undergo acidic medium to get something into this product, which is obviously a cation. Okay, and it can also undergo a basic medium to form something like this is anion, and this is obviously inner salt or zwitterion. Okay, so the H plus concentration at which the particular amino acid does not get influenced of the electric field, it is called isoelectric point. Okay, so the H plus ion concentration at which a particular amino acid does not get influenced of electric field is known as isoelectric point. Isoelectric point. Okay, so at isoelectric point, concentration of cation is equal to concentration of anion. So at isoelectric point, concentration of cation is equals to concentration of anion. Okay, that's why it doesn't get influenced by electric field applied on the top of it. Okay, so or you can also say that at isoelectric point, net change on particular amino acid is 0. So at isoelectric point, net change on amino acid is 0. Okay, so let's actually go into the derivation of the pH at which it will reach the isoelectric point. Okay, so let's delve into it. So we have something like this, converting itself into rather a H plus also here, or we can say let's have a O minus here, and this was actually getting converted into a cation. Okay, so we are getting CO2H plus or rather let's take this example only. We have CO2H here, CO2 minus is formed here, okay, plus H plus. Okay, so the K1 for this reaction would be similar to this. Let's call this zwitterion as Z. Okay, concentration of Z, H plus, and concentration of anion or rather cation. This is our cation. Okay, next let us see this reaction in which we have something like this. it is getting converted into NH2, CH2 and CO2 minus plus H plus. So this is our, the K2 of this reaction would be concentration of anion, this is our anion, concentration of H plus divided by concentration of, this is our deuterium, concentration of Z. Okay, so at Pi, what will happen is, Pi is nothing but isoelectric point. The concentration of anion would be equal to the concentration of the cation as per the definition of Pi. Then from the first equation and from the second equation, concentration of cation would be Z multiplied by H plus divided by K1, Z multiplied by H plus divided by K1, and the concentration of anion from the second equation would be K2 multiplied by Z upon H plus. Okay, so from the two equations we can cancel out the concentration of Z, and we can have pH concentration whole twice here, left hand side, K1 and K2. So obviously we'll take the log at both the ends, and we'll have here, what will we be having? We can have log of root of K1 times K2, and here we will have log of H plus. So what is the pH at which it there would be having a isoelectric point? So this is the pH. Okay, log of H plus is nothing but pH, and this is half of pKa1 plus pKa2. Or directly write pK1 plus pK2. Okay, so this would be the pH at which there would be equal concentration of anion and cation amino acid. So this is Pi. Okay, so let's actually have some examples here. So let's suppose we have this NH3 plus here. Okay, and we have CO2H here. pKa of this value, this CO2H is this, and pKb of this compound is 5, or this NH3 plus is 5. So what would be the Pi or pH? It would be half of pK1 plus pK2, which would be 2 plus rather this is not okay, so this is pKb, right? So first we have to convert it into a pKa value. So pKb, we know that pKb plus pKa should be 14. So pKa for this case would be 9. Okay, so pK1 would be 2 plus pK2 would be 9. pK1 was 2, pK2 is 9 divided by 2, which is 5.5. Okay, so first we have to convert this pKb into a pKa, or in other words, you have to convert it into NH2. Okay, so anyhow you can do it, but if pKb is written, you have to convert it into a pKa value. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same concept. Till then, good luck and goodbye.